kids, we are back with another super interesting video. Ever wondered why the color blue is so rare? Blue is a very prominent color on earth, but when it comes to nature, it's very rare. Although animals come in all varieties of color, how many can you think of that are actually blue? There are no blue tigers, no bats, no squirrels, no blue dogs. Even blue whales aren't that blue. Animals come in pretty much every color, but blue seems to be the rarest. What's cool is that when we find a blue animal, most of us get mesmerized by its beauty. There are the less common but far more striking creatures with eye-popping blue colors, such as butterflies, frogs, and parrots. That's because nature doesn't do halfway with blue. Less than 1 in 10 plants have blue flowers, and far fewer animals are blue. So why is that? Why is blue so rare and uncommon? Most pigments that animals exhibit on their fur, skin, or feathers are related to the food they consume. Salmon is pink because of the pink shellfish they eat. Goldfinches get that yellow color from the yellow flowers they consume. But while pigments like red, brown, orange, and yellow come from the food animals eat, that's not the case with blue. In fact, that blue you see is not really a pigment at all, not just in animals. The color blue is rare in the plant kingdom too. That's because it's a tough color to spot in nature, because there is no naturally occurring blue compound to color things blue. Before I tell you why blue is rare, let's first understand why we see blue or any other color. All light is a form of electromagnetic energy waves that can travel through a vacuum. The waves fall on a spectrum, with some having longer or shorter wavelengths. X-rays, microwaves, and radio waves are all part of the spectrum, each with their own wavelength. There's only one sliver of the spectrum that we can see, and that's the visible light spectrum. If you zoom into the light energy, you will see each color is having its own wavelength. Reds and yellows have relatively long wavelengths. Blues and violets have the shortest. The color we see is the wavelength that reflects most from that object. Take a yellow sunflower for example. It first absorbs the blue, red, and other color energy waves and then reflects back wavelengths that appear yellow. The color receptors in our eyes then translate the flower's wavelength into its color and send that to our brain. So how do the true blue plants, animals, and minerals get their color if there is no actual blue compound? It's all in how these organisms are built and how light bounces off these structures. It's actually called structural color. Light hits special structures on the cell, wing, or other part of an organism. This causes the wavelengths to bounce in a very short wavelength, resulting in the formation of blue color. That's all for today, kids. Hope you now understood why blue butterflies and blue creatures are so rare. Thank you for watching the video. If you have any questions, you are free to ask in the comment section below.